students, today's agenda is to check homework. We'll be graphing mixed parabolas and you will be able to work on 11.6. Today, students will be able to graph parabolas from different types of equations. And just a reminder, if y is isolated and you have x squared, then the parabola will open up. But if the x is isolated and y is squared, then my parabola will open sideways. But if both x and y are squared, and then you have a value in here, then that forms a circle. Okay, that does not look like a circle. Okay, it says graph the following. As you can see, this is not in any kind of those forms. So what you want to do first is to add y to both sides. This cancels and you get y is equals to x plus 3 squared plus 4. And now when it's in this form, then you have the x, the opposite of the x value, and the y value for the vertex. Okay, and you can already just do the mother graph since we've been looking at this for 2 other videos. You can do the mother graph and then just do the transformation, right, the shifts. Or you can just find values. And for this first one, I'm going to find values. So the vertex is going to go there. And remember that we always get, when it's in parentheses, we always get the opposite of the x value. So if it's positive 3, it will be negative 3 for the vertex. And this one, you just respect it. So basically, this will go to the left and this will go up because this is in relation to y. This is in relation to x. Okay. Inside of the parentheses is the opposite. Outside, we just follow on that variable, whatever it says. It's positive 4, then you go up on y. And for the other x values, you just add 1 plus 1 will be, well, negative 3 plus 1, that's negative 2 plus 1, negative 1, because it's like paying $1. You owe 3, but you're paying, that means your debt is less. In here, it's going to be negative 4 and negative 5. Now, if you put this up here and this down here, it doesn't matter. It won't affect. And then from there, you start finding the values for y. So it's going to be y is equals to the value of x, which is negative 1 plus 3, and square that, plus 4. Okay, and then you get negative 1 plus 3 is positive 2 squared, and you don't need the parentheses because it's positive. And negative 2 times negative 2 is 4 plus 4. That gives us 8. So that's my first value. For the next one, y is equals to x, but the x is going to be negative 2 plus 3 squared plus 4. All I'm doing is substituting that x, okay, by the values that we chose in here. And so in here we have 1. Again, you don't need the parentheses. I don't know why I'm writing it. And so 1 times 1 is 1 plus 4, which is 5. And the reason for which you don't need the parentheses in here is because it's only when it's negative that you really do need the parentheses. But if you don't put it in there, it doesn't really matter. So in here, what we're going to do is that we should get these two to be the same. So I should get a 5 in here and an 8 in here. And let's just do it to show that it is true and that I didn't make a mistake on the other ones. So again, it's equals to x, which is negative 4, plus 3 square plus 4. And negative 4 plus 3 is negative 1. Now I do need the parentheses. And negative 1 times negative 1 becomes positive 1 plus 4 gives us 5, which is our value for y. And the last one is negative 5 for x. So negative 5 plus 3 square plus 4. Negative 5 plus 3 is negative 2. Square that plus 4. And negative 2 times negative 2 becomes positive 4 plus 4 gives us 8. So that's our values. I'm going to graph the values, and I'm not going to graph the mother graph so that you can see. -1, +8 is -1. 1, 2, 3, 4, 5, 6, 7, 8 is right there. -2, +5, 1, 2, 1, 2, 3, 4, 5, right there. Then the next one is -3, 4, -3, +4, right there. And the other ones, you can easily just say, oh, if this is that, like that's the distance, then it's going to be here. And then I go 2 and 4. And the reason is because the mother graph was here. So 0, the mother graph is just y equals x squared. Okay, and then those are the transformations that you're doing to that. So x, and then if x is 1, 1 times 1 is 1. -1 times -1 is 1. And then if x is 2, 2 times 2 is 4, which is right here. And -2 times -2 is +4, which is right here. So that was my mother graph. In here we have the new transform graph. But look at what we did. We said that it was -3, so if you didn't have, or you decided not to do this work, you can just go 3 spaces left and 4 up. For the vertex, you go -3 on that variable, so on the x, you go -3, 1, 2, 3, because it should be the opposite inside of the parentheses. Outside, you follow what it's saying. It's +4 on y, so 1, 2, 3, 4, right there. That's my new vertex, 3 and 4. And then from there, it's 1, 1, 1, 1. Just looking at the distance right there. The other one was 2 from the vertex, 2 spaces and 4. 2 spaces on the left and 4 up. So 2, 4, and then 2, 4. Okay, so that's how you get without doing this work. That's what we're going to be doing on the other ones without doing the plotting points. But if you feel more comfortable plotting points, you can go ahead and do that. Okay, let's look at number 2. And I want you to notice something of a difference. So if you notice, in here we have x to the second power, y to the second power. And even though it's not set up in this form, we said that if x and y both are squared, it's not going to be a parabola. It's going to be a circle. Okay, so whenever you see that both x and y are squared, then you know that it's a circle and that you need to have it in this format, but equals to the constant numbers. So we're going to cancel that -4 by adding it to both sides. And we end up with 0 plus 4 is 4. X plus 3 squared plus y plus 3 squared. That's the standard form to graph a circle, okay? And so for the center, you get the opposite of what is being added or subtracted to x. In this case, it's +3, so it's going to be -3. The opposite of this is -3. Why do we get the opposite? Because it's inside of the parentheses, okay? If it's inside of the parentheses, then we change the sign. And then the radius will be the square root of the answer. In that case, square root of 4 is 2. So 2 spaces. So now that we have our center and our radius, we can go ahead and graph it, which is -3, -3. That's my center. And then you have to graph it with a radius of 2 spaces away. So that's right there. And so we put it as close to the center as we can. I know it's not easy. And then we start turning our page. Okay, so when both x and y are squared, you get a circle. Okay, now number 3. First, what we're going to do is cancel by adding x to both sides. And 0 plus x is just x, which is equals to y squared. Well, we said that when x is isolated, and this is just the mother graph, we don't have any transformations, we're not subtracting or adding anything to y, and we don't have anything outside either as a constant. So that means that you're just going to square y to find the values of x. And so if y is 0, 0 times 0 is 0. Then if y is 1, then 1 times 1 is 1. And if y is 2, 2 times 2 is 4. So that's how I get that part. We know that if we put negative, -1 times -1 is +1 as well for x, right? If y is -2, then x is going to be -2 times -2 is +4 right there. And that's my graph. Again, if x is isolated, then the graph or the parabola is hugging the x-axis, okay? And that's just our mother graph, basically. For number 4, we had a square in here to make a circle, but I decided to take that away so that I can show you something else that is important in here. So I'm going to isolate y by subtracting x squared. This cancels, and I'm just, well, let me rewrite it. So y is equals to -x squared plus 1. And I'm going to rewrite this as y equals, so I'm just switching the two sides of the equal sign. -x squared plus 1. I brought the x over here and -x squared plus 1 on the other side. And if we were just doing the mother graph, this will tell me two things. That this will go one space up, and this is a mirror, a reflection on x, okay? Just because it's outside of the parentheses. But what I want to do for this one is to also create a table so that you can see how the graph ends. And I don't know, maybe I should try to graph it. Maybe I should try to graph it before so that you can see that we do end up in the same spot. So the mother graph, when y is isolated, the mother graph is just y equals x squared, right? So it's going to be right here. You're probably so used to them, but if you saw the previous two videos. So that will be my mother graph, which is y equals x squared. With this transformation, it says that it will go one spot up. Okay, so I'm just going to do it with with a light color. So one space up because it's 1 on y, right? So it's going to be right there. But then it says that it's going to mirror on x. There is no parentheses. The negative outside of the parentheses means that you're going to see your reflection on the lake because you're outside camping. So the 1 would actually go right here, and this one would go right here because it's backwards. See, instead of like this, you're going to, well, it flips like that. Okay, and then from the vertex, from the new vertex, which is at 1, 1, which is at 0, 1, it's also 2 spaces, and then right there, 2, 4, and then 2 spaces and 4 spaces right there. So my parabola, if you can see, should go through there. Something like that. Okay, now let's check with our plotting points to make sure that that's where it's landing. Again, you go one space up, and then instead of going the 1, 1, 1, 1, 2, 4, 2, 4, you will go from that vertex 1, 1, 1, 1, 2, 4, and 2, 4. Now let's do by plotting points, see which one you like better. So for our vertex, we're not adding or subtracting anything to x, so that's going to be 0. Okay, remember that it's adding or subtracting. And for y, you just respect the sign, so it's positive on y, so it's positive 1. So that's my vertex. Okay, and then for the other values, you're going to add 1, so 0 plus 1 is 1, plus 1 is 2, and then subtract on the other side, so -1, -2. And we start finding those values. So y is equals to negative x squared. We're going to put parentheses because the square is only for the value of x, not for that negative. And that negative, you're just going to carry it over. And okay, so negative is going to be outside. The 2, we put it inside the parentheses, and that's square, plus 1. We carry the negative. Again, we just bring it over. And positive 2 times positive 2 is 4 plus 1. So that negative 4 plus 1, negative 3. That's our first value right there. For the next one, y is equals to, again, that's the negative. We just keep it from the formula. The one that we're going to be replacing is just x by the number 1. Okay, and that's square. This is what's going to be squared, not the negative, and then plus 1. Okay, so 1 times 1 is 1. Bring down the negative, plus 1. That gives us 0. Again, this should be the same. Okay, so we're expecting a 0 in there. Now y is equals to, bring down the negative, replace the value of x, which is negative 1 squared plus 1. And then some people would say negative times negative is positive. No, remember that we have to do exponent according to PEMDAS, exponent first and then multiplication. Okay, the multiplication of the signs don't happen before the raising to the second power. So bring down the negative, and negative 1 times negative 1 is positive 1. That negative is just from the one that we have here. Plus 1, negative 1 plus 1 is 0. Yay! They match. And then the last one, y is equals to negative. We open the parentheses to substitute the x, which is negative 2 squared plus 1. Again, we don't multiply negative times negative. Careful. We do the power first, the exponent first. So negative 2 times negative 2 is positive 4. And just bring down that negative, plus 1. Negative 4 plus 1, negative 3. And so now let's plot them. 0, 1 is 0, 1 right there. 1, 0, 1, 0 is right there. 2, negative 3, 1, 2, 1, 2, 3 right there. For the next one, negative 1. So from the origin, you go negative 1, 0 right there. And negative 2, 3, negative 2, negative 3 right there. As you can see, they do fall in the same spot than if you did the transformation only without doing that, okay, without plotting points. For the next one, I'm going to isolate y by adding this entire term, and I do that to both sides. This cancels, and I get y is equals to x plus 3 squared plus 4. And whenever you have y isolated but the term of x is square, remember that the mother graph is going to be y equals x squared, which we have our graph to be right there. Again, if you're not sure about this, you should watch 11.4 and 11.5 before doing this. And if you're getting it, that's fine. Let's keep going. So remember that if it's outside of the parentheses, it just follows what it's saying. So it's telling me that it's going to go up 4 spaces because this relates to y. In here, inside the parentheses, is always opposite, and if it's positive 3, it's going to be negative 3 but on x. So x is the x-axis side to side. So it's going to the negatives instead of positives. Okay, remember inside the parentheses is opposite, outside it follows that sign. on regards to the lonely or isolated variable. Okay, so if that's my mother graph, it's going to go 3 spaces to the left. So 1, 2, 3, 4 up, 1, 2, 3, 4 right there. And remember that you have 1, 1, 1, 1. So we're just going to find it that way to make our lives easier. 2 spaces and then 4 from the vertex. So 2 spaces and then 4, 2 spaces and 4 right there. Number 6. In here, what we're going to do is to Number 6. What we're going to do is to add 3 to both sides. This cancels. And so x will be equals to y minus 1 squared plus 3. And you can leave it like that, or if you need to, you can just switch them, okay? You can put x is equals to y minus 1 squared plus 3. But if you leave it like that, it's the same thing. You just look at this as the transformation. Remember that this tells us the opposite because it's inside of the parentheses. And if it's negative, for y, you would go down, right? But because it's the opposite inside of the parentheses, you're going to go up 1 space. And this is related to x. It's related to whatever variable is in there, but you follow the sign. So it's positive. That means that it's going to be positive on x. Okay. So again, if it feels more comfortable looking at the equation this way, you go up on y because it's the opposite, and that one is positive 3 on x, so you just go to the right. We said that the mother graph for isolated x is x equals y squared, which is right here, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. That's my mother graph. Okay, but in here for the vertex, we're going to go 1 space up, 3 spaces to the right, 1, 2, 3, right. That's where my new vertex is, right there. And the other ones is just 1, 1, so right there, and 1, 1, and then 1, 2, 1, 2, 3, 4, and 1, 2, 1, 2, 3, 4, right there. So that's my new transformed parabola. So as you can see, a lot of this is review from previous lessons. The only difference is that now they're mixed and you're having to do different things to different ones. Last lesson, you had to do only completing the square, but in here is canceling or completing the square or looking if it's x or y. And here is one where you have to actually complete the square because you don't have any parentheses. So the first thing you want to do is to add 11 to both sides. This will cancel and you get 0 equals, you rewrite this whole thing, x squared plus 6x minus y plus 11. And now you're going to get rid of the y by adding y to both sides. This cancels and you get y is equals to 2. And what I'm going to do in here, from the previous lesson, we learned that we're going to add and subtract something so that we can just add 0. So I'm going to leave those spaces in there. So x squared plus 6x, leave a space, plus 11, leave a space. Okay, and if you recall from the previous lesson, what we're going to do is basically complete the square in here, but we can't just do the same thing. And so I'm going to put x in there, divide by 2. 6 divided by 2 is positive 3. Whoops. And that's going to be squared. Remember that this, we take it to the second power, and 3 times 3 gives us 9, so we add 9. And what we would do, we would add 9 on the other side, but you would have to subtract it from both sides. So we just might as well just subtract it. What are we doing in here? By adding 9 and putting a -9 as well on the same side, what we're doing is just adding 0, because +9 and -9 is 0. So basically we're not changing the x squared plus 6x plus 11. Okay, so now this is the complete square right here. Okay. Whoops. So in here you have x plus 3, x plus 3, x times x is x squared, 3 times x is 3x, x times 3 is 3x, and 3 times 3 is 9. That's this area, and that's why we needed to add that 9 in there, because now we have x squared plus 6x plus 9 that we didn't have. And this x plus 3 to the second power is this dimension. X plus 3 to the second power just means multiplying times itself to get that area. So basically this is in area form, and this is the dimensions being multiplied, okay, which is equal to each other. However, now we need to simplify this part, and +11 and -9 gives me +2 equals y. Now we have that transformation, right? Let's rewrite it as y equals x plus 3 square plus 2. So let's graph it, but remember that this means the opposite on x, and this means follow it on y, meaning that if it's y +2, then you go up. The mother graph for a parabola will always be 0, 0. 1 times 1 is 1. -1 times -1 is +1. 2 times 2 is 4. -2 times -2 is +4. And that's our mother graph. Whoops. Okay. And our transformed parabola will be -3 spaces, +2 spaces. That's my new vertex. So 1, 1, 1, 1, 2, 4, right there. 2 and 4 right there. And that's my new transformation, or my new graph. Okay. Okay, so let me show you just this part right here. And I'll bring it over here. So if I have just that step, x squared plus 6x space plus 11, and then I put equals y, okay? So if I decided to do it this way, and I say, oh, I just put x, I divide that by 2, which gives me 3, and that's square, plus 11 so far, right? Or actually, I shouldn't put it yet. And then if I add this, 3 to the second power means 9, so I add 9 in here, and I add 9 on the other side. Remember that whatever you add on one side, you have to add to the other side, okay, to maintain the equality. So this gives me y plus 9. However, I want to leave y by itself, so I'm just going to subtract from both sides. This cancels, and I end up with y equals, and then in here I just bring down this part, which is x plus 3 squared, and 11 minus 9 is +2. So see, at the end is the same thing. If you put this, whatever you add to one side, you add to the other, or you just add 0 in here by adding the 9, and the -9 you are adding 0, okay? In here you end up with this +9 that we have in here, and this -9 that we cancel, which is this right here. So you're just adding 0 and not changing or manipulating that part. Number 8, in here I see that y is isolated, and I don't have x squared. However, we have this that can be done as distributive property, and when we multiply this, we end up with x times x is x squared. Oh, so that's a parabola. X times 4 is 4x, I have negative y equals negative 4. And I'm going to do one step at a time so that we don't get confused. First, I'm going to get rid of the y. And I get x squared plus 4x equals negative 4 plus y. Finally, I'm going to add 4 to both sides. And so y is equals to x squared plus 4x plus 4. And some people can already see that this is a perfect square. How do we know if something is a perfect square? If you do this, divide by 2, and take the square root of including the sign, because this one always has to be positive, and you get the same answer, then that's a perfect square. Okay, how do you do that? Well, 4 divided by 2, just bring down the x, and 4 divided by 2 is positive 2, and the square root of 4 is also 2, which you would have to add. If you didn't have that perfect square, it would be raise this to the second power. 2 times 2 is 4, which is already there. Okay, so we already have the perfect square. So to graph this, what we're going to do is our mother graph is right there. Okay, now for the transformation, you're not adding or subtracting. Let me rewrite it. You just have this right here. You're not adding or subtracting anything, so that means that you're not going to move anything on y. You're only going to move on x, and it's the opposite, okay, which is to the negatives. So 2 spaces to the left. So 2 spaces to the left, 1, 2, right there. And then from there you do the 2 points, which is here, and 2 spaces and 4, and 2 spaces and 4 right there. So that's my transformation. This took a little bit more steps because first of all you have to do this distributive property to get the one that is squared, and then cancel things, and then find out that it was already a perfect square. So yeah, look at your assignment and look at the structure and see which one does it look like, so that you can start canceling and moving things around. And now you're able to do 11.6, but before that, if you can just give us a thumbs up, subscribe around here. Here is the list for the entire unit, and here you can find the next video. Don't forget to be happy and have fun.